pin on the map. And then all of the other little pins come in, and that becomes our sale. I decided Fort Collins that people buy a lot of big screen TVs, or what do they buy primarily? And what about this side? Can I break you up into data patterns across Fort Collins so I can target market in the local newspaper? Spam, I can do all of that. Same concept, dependent map variable, independent map variable. That says agriculture is more like geobusiness, certainly, than it is natural resources. That's more like infrastructure. Keep track of the roads. That's what they were doing originally, spatial inventories. See how they came at the same technology with radically different motivations, goals, backgrounds, objectives. Let's see where they're moving today, both natural resources and ag. Well, we have this precision ag thing. And that's where we stack up all these little maps, and then we go off and analyze them, principally in two-dimensional space, coincidence, that kind of what's here and here and here and here and here, same place, but the different information. And let's see if we can use that to manage the field better on a variable application, management action basis. It's kind of an isolated perspective. Look at that field. It's just hanging out there. It's not connected to anything, and it has a production. They want to do good production. Let's look over here at something that's just started up in the last few years. Precision conservation. Been around maybe as a word for 5 or 6 years. There's some conference tracks that are in precision conservation now, particularly Soil and Water Conservation Service. Well, now they have a different focus. Rather than being individual field focus, it's taking a landscape focus. But it says, can we use this technology on the landscape now? And in that case, I'm not so much coincidence-oriented as I'd like to see flows and cycles across here. How do things move from one place to the other within an ecological context? Individual field scale, farm, watershed, region scale, landscape, production focus, process sustainability focus, optimizing 2D coincidence, characterizing 3D flows and cycles, isolated perspective, interconnected perspective. That says precision agriculture contributes a lot to this field. But so does natural resources moving into that space, and so does environmental science move into that space. That's what I meant by these fields that started out paradoxically so far apart. As we move into advanced spatial analysis, they're starting to get closer and closer together. Here's the example. Natural resources. Stream. Salmon spawning stream. Got to protect the fish. Why, we'll push that button that says buffer in ARC, and we'll put a simple buffer around it. No dirt disturbing activities within 300 meters of that stream. Ha! We saved the salmon. Probably not, because up here, you just told them they could do anything they want at 301 meters. They're going to dig all sorts of dirt, it's going to roll down the hill, and cloud salmon romance again. Over here, you just told the logger, oh, you can't cut any of the trees in here, you can't do anything in here because it's within that buffer. Well, look at all those little hairs, perfectly flat, little dirt balls that have to jump up and down and crawl to get into that stream. You have messed with the logger, and you've still killing the salmon. Why? Because you have a 30,000-year-old paradigm of mapping in a modern age of the digital computer. let's try. But all buffer feet are not the same. You need to reach farther under some conditions and not as far under others. Well, let's just try a simple erosion potential model. Well, here's that slope map. Remember we went in and fit that plane, and if it was steep, slope, and so we have slope. The other thing we did down here was kind of curious, is we pretended, kind of like that optimal path. In fact, it is the same algorithm. I dropped a raindrop. It's going to go down dirt hill as fast as possible, and I'm going to keep track of everywhere it went. Then I'm going to move over a square. Why, this place, 2 uphill paths went through me. Whoa, over here, 3, 4, 5, 6. It's called a flow accumulation map. So just here we tell you how steep it is everywhere, but down here we tell you how much water is flowing there. Now just common sense, these erosion potential get fancier, but if I'm steep and there's a lot of water running down there, I'm a gully washer and I'm going to dig a hole. I'm going to move dirt like mad. Well, that's what this next step does. It takes this guy, turns it into 3 classes of steepness, takes this guy, turns it into 3 classes of flowness, light, moderate, heavy flows, and then jams them in together for an overall. Where 3-3 means it's, wow, heavy flows of water there, and it's steep, dirt rippers. And where it's 1-1, there's light water flows, and it's gentle. I'm probably not moving dirt. In fact, I'm probably collecting dirt at that location. Erosion potential model for every one of my little squares. There's 10,000 little squares in there. Small project area. Take that stream. Oh, we've learned so much about effective movement. Move out from the stream, but this time when it goes splash, I go 1 away, 2 away, 3 away, reach farther under high erosion. Don't reach as far across locations along the stream that have low erosion potential. And now what I have is a variable width buffer that's smart. It's not dumb. It's not 30,000 years old. It says, if you go to the yellows, boy, way away from the stream here. Oh, not so far there. A variable width buffer could save the fish and the logger. Wouldn't that be amazing? Brought to you by geotechnology, your field. A mega technology. We're not just helping people get to the pizza parlor. We're changing science. Oh, but let's see, what do they do on the farmer's field? Well, why don't I create a slope map of the farmer's field? Kansas. Kansas has flown their entire state using LiDAR, and they have a 2-inch elevation model over their whole state. 2-inch change in elevation. Well, now all of a sudden as a farmer, and that's why they did it, is I can now look at my farm as being a terrain, a micro-terrain. And how about I do that slope with flow? And put that together into a surface flow map that says wherever it's red, you know, there's a lot of movement. When you put down your chemical at that location, it has a tendency, particularly if it rains soon, to go somewhere else. All the fines in the soil, the plant really likes fines, tend to go to somewhere else. And at the edge of the field, I really like to look at that because it tells me where runoff goes off the edge of the field that may contain ugly stuff. That is the same mindset as this. The two fields are coming together over being smarter about their stewardships. Now we're getting really smart. Right about the 100th meridian splits the U.S. between wet and dry. different laws on the wet side versus the dry side. And on the dry side, we have something that's called first in time, first in right. That means if you got here early and you said, I want so many acre feet of the Poudre River, and you filed for it, you got it, you own it. Whether you're going to use it or not, you own it. Well, what that's been doing is kind of messing this up with something that's called buy and dry. It was okay until maybe the 70s. And then in the 70s, thirsty little metropolitan areas needed water, but they weren't first in time to get that much water. So what they would do is they would buy farmland, still do, for the water rights. They're not going to farm the silly thing. They're just going to buy it and dry it up. Move the water to the city. We've got lawns to water. Well, by law, they have to retain the surface and subsurface flows. But there's this thing called the consumptive use that they actually move from Brighton down into the city of Denver, for example, when I buy that farm. Well, this is a very interesting idea. Temporary monitored transferable rights. If you've been into any land use thing, they have transferable development rights. There's transferable rights to do with wetland mitigation. There's all these little banks have been set up for transferring things. Well, this is transferring water rights. Don't sell it. Lease it. And if we can find out of that consumptive use, yep, I'm going to use it to grow my crop. But if I can identify what I don't need, I can sell it or lease it. I make money as a farmer. Ooh, that sounds good. And the city gets its water, and we still have a crop. That is pretty revolutionary. And this is what it involves. A whole lot of CSU sits in this. It's called Regenesis, is the lead organization. But there's a lot of governmental organizations and a lot of private industry trying to pull this thing off, where they're identifying the on-farm data, off-farm data collection that's needed, and the on-farm. So they can monitor, make sure, make the farmer feel good that I'm going to have enough for my crop. But I have more acre feet available to me, I'll sell it on the market. Regenesis. There's a little place to go take a look at it. If you're with the Warner College of Natural Resources, a major actor in Regenesis is Ed Warner. It's his passion of a company. And Bob Stoller is also Warner College, is the other major actor in that. So that's the lead agency. Might take a look at it. It certainly is, to me, one of the phenomenal applications of GIS technology. Okay, upshot. Natural resource was an early adopter. Ag had little use for maps. That's important. Where did they come from to get here within a historical setting? In terms of their contemporary GIS applications, both of them currently are primarily using it as technological tools to navigate, to do geoquery and things like that. However, on the analytic front, currently, stewardship and economics at the field level using spatial statistics for ag, but for natural resources, spatial analysis, landscape level, ecology and environmental impacts. Future. I think they're going to be pushed and pulled together because science, I think, is moving into this arena. Natural resource will incorporate more quantitative analysis. Right now, my background is natural resources. We are still doing non-spatial statistics whenever we go to our science. Not on the other side of campus. And in their case, they're kind of going to move their idea a little further about the movements of items, flows and cycles. go to that location. It's on the handout that's over there. And you can look at the videos, you can look at the PowerPoints, you can look at references off of there. Go to here, you get to look at a whole bunch of other papers all around, all around in here, and all that, a whole bunch of papers. And one of the important ones being this book, online free book, so I'm not making any money off of this, Beyond Mapping Compilation Series. Topic 10, Book 4, GIS Modeling of the Natural Resources. They're scattered throughout their agricultural uses. I use that with a lot of my examples. Okay, questions other than how come the parade isn't there already? Or it's coming at us. Any thoughts?
Do combines already have, or do combines exist, I guess, that have this ability to go over these squares with differential needs, yes, I suppose, and squirt out nitrogen or something, for example, at differential levels?
That's one thing about agriculture, is their science is pushed and pulled by their grease, I'll call it, the grease and gears infrastructure of ag. So who pushed all of that was like Ag Chem, John Deere, all of those folks said, this is a market where we could do variable rate if we could figure out how, using GPS, we could control everything back there. No, they control seeders now. When the seeder goes out, it doesn't just put the same number of seeds in the thing. It'll pick it up where it's needed and push it down where it's not. They've done lots of things. Natural resources, we don't have a gear and grease industry that's pushing and pulling us anywhere. We kind of have cranky, well, I better not say cranky, concerned publics. And so far they've been happy just looking at colorful maps, principally.
I was going to ask a probably related question about the metrics that they gather for the effectiveness of what they're doing with ag. You know, the seeds that you mentioned, like, is there a feedback where this is what we're doing, this is the result, and it keeps getting better and better?
There actually is, believe it or not. Because when you have a prescription map, this is what I want to do. But, you know, sometimes the equipment can't change that fast, or something going on. The guy's driving too fast or something. So they actually keep an as-applied map, and that becomes a dependent variable that they relate and see whether it works or not. Now, that's not done on every farm, but once you buy in, like let's say you're in a co-op and you buy into the variable rate, they take, back to this idea of who owns the data, they got your data and they mine your data to see how it's working and improve the algorithms.
And it'll make the overall system better.
Yes.
Right? That's the idea. Yeah.
Well, just like GeoBusiness, I'll make your experience in Best Buy better if I watch you swipe cards.
Going back from last session, one of your takeaways, or one of the things that I still, you said there was a 30-year cyclical period where we go from data collection to data visualization to data storage. And right now it seems like we're in data storage. What do you think in the next 5 to 10 years we'll see in the data storage side? Do you think we'll be doing more object-oriented? Do you think we'll be doing more NoSQL? How do you think data storage is going to change over the next few years?
Okay, I'll hit that one, but first I'll say the years I bumped into it started out with display, that we wanted to draw a map, for example. And then it went to this idea of data structuring. We wanted to link our digital maps to attribute data. So it goes display, data structure. Then we said, wow, now that we got this in the computer, we can analyze it. So that was 30 years. Then we hit this, I'll say, the past decade, 2000 to 2010, we said, whoa, what about that display again? I can push it out over the internet. I can do all of this. So we did that. I think where we are right now is what you suggested. We are doing data changes. Now it's, you got to be with the kind of research side of these companies, but they're frantically trying to improve. And in addition to that idea I presented, where we're going from squares to hexagons, cubes to dodecahedrals, yeah, we're doing that, particularly in the military. They have to move cruise missiles and they can't move them on little flat maps, for example. They gotta go up and over hills and all that kind of stuff. So they've gotta work in 3 dimensions. But the other one that's happening is BIM. Ever heard of BIM? Building, what is that, management, building infrastructure management, something like that. I forget what the
Building
I is.
information.
Information.
Yeah, I think, yeah.
Well, BIM is what we used to call solid CAD. And it is object-oriented. It does know that this bolt connects to that manifold that holds on that goes to this. Their maps, if you will, we used to call them drafting documents, but their maps are much smarter than our maps. I'm working with a fellow in Australia, Adeline University, that's that university's lead research is how can we take GIS and make BIM more GISing, which probably too naive. I think it's pretty easy. Just throw away your damn XY coordinates and put in latitudes and longitude, and we're probably there. But more importantly to me, how do we move that intelligence into GIS so it really knows something about what's around it, who's it's connected to, what side of the road it's on, without calculating. So that's going on now. And my guess is, soon as we finish that in this decade, we're going to change all of our algorithms again to take advantage of the new data structures. And maybe back to display, that iWatch. A conference I went to a week or so ago, yes, they had an iWatch there, but they also had Google Glasses. Oh, God.
So specifically with data storage, how do you see it changing? More object-oriented or more?
Yeah, definitely more object-oriented.
More, okay.
More intelligent in the map.
All right.
But don't confuse that with spatial objects. In other words, I think we're going to move away from polygons, personally, but remember I'm a raster head. It's just inefficient. And since at the very end you display it in raster anyway, why wouldn't have you done that in raster? It used to be, I'd have to keep track of, all I'd have to do is XY, 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 XI, XY, and if I just stored the boundary, that would be smaller, and if I stored a whole bunch of, yes, I'm a Doug first hand, yes, I am too, I am too, I am too, I am in too. So we had this storage problem. Well, there ain't any more storage problem. You can work with horrendously large rasters in a database system. Adding to that, next week or next time, I'll talk about boutique to big box. The big box industries, the Oracles, the Googles, the Sybase, these are big data crunching, big data with big data. They think of maps as rasters because it's computer organized. They didn't come at it in database technology, in statistics technology, math technology. They didn't come at it as points, lines, and polygons. So they're gonna completely change the landscape because I think they're gonna go all raster. Any other thoughts? Go Rams! Volleyball, 6 o'clock streaming.
All right.
You can see volleyball.
Thank you.
Thank you.
Thank you.